Now the next question is, if we select this order 3 here, now corresponding to order 3, how many such elements would be present? That is what, out of this 5040 elements, how many such elements are there which would have order 3? So let's calculate this thing also using the result. So in order to do that, what we do, we are looking for permutation of 3 cycles. So that means we are looking for cycles of this form A1, A2 and A3, where this A1, A2 and A3, they are some member from the set A, which is 1, 2, 3, 4, 5, 6 and 7, correct? So and we are also looking for the permutation of this kind, where we have 2 disjoint cycles, each of length 3. So it will also have order 3. Why? Because LCM of 3 with 3 is going to be 3, right? Here the LCM of 3 is going to be 3. So that is why we have the order of both of them as equal to 3. Okay, so for proceeding, firstly we'll be looking at this cycle A1, A2, A3. Now we have to look in how many ways can we select A1, in how many ways can we select A2, and in how many ways can we select A3. For that, what we do for selecting A1, because in total we can place 1 to 7 all the numbers in place of A1, so therefore we have 7 choices here. Now once A1 is fixed, for A2 we have the remaining 6 choices, so we are multiplying it with 6, and then for the last element A3 we have the remaining 5 choices, because now A1 and A2 both are fixed, right? So we are multiplying it with 5. So clearly the triplets of this kind, they would be 7 into 6 into 5 times. These many triplets would be there. But in this triplets, because we are treating A1, A2, A3 as different entities, different numbers, so therefore it would consider the elements A1, A2, A3, A2, A3, A1 and A3, A1, A2 as different. However, within a permutation, this is the same thing. Why? Because suppose we are taking this number. So writing 1, 3, 4 is equivalent to writing 3, 4, 1 is equivalent to writing 4, 1, 3. Why this is so? Because in this 1 is mapping to 3, 3 is mapping to 4, 4 is mapping to 1. In this also 3 is mapping to 4, 4 is mapping to 1 and 1 is mapping to 3. In this also 4 is mapping to 1, 1 is mapping to 3, 3 is mapping to 4. So all of them, they represent the same permutation, and that means they are equivalent to each other and the same thing. So therefore we are counting such pairs, such triplets as different, however they are the same. So that means we have to divide this sum by 3. So this is what we are doing, because they are the same. So therefore the number of permutations in S7 of this kind, A1, A2, A3, is obtained when we have 7 into 6 into 5 divided by 3. So in total, when you calculate, this comes out to be 70 in number. Now looking at the other permutation, which is the product of 2 disjoint cycles having 3 orders. So it is A1, A2, A3 and A4, A5, A6, where all this A1, A2, A3, A4, A5 and A6, they belongs to the set A, which consists of all the numbers from 1 to 7, right? So now for choosing the elements here, for choosing the numbers A1, A2, A3, we'll proceed by the above manner, and we would obtain these many numbers for this. So we have 7 into 6 into 5 divided by 3 choices to create this triplet A1, A2, A3. And for the second one, A4, A5, A6. Now you see A1 is fixed, A2 is fixed, A3 is fixed. So that means we are now left with 4 choices. So out of 1, 2, 3, 4, 5, 6, 7, we have already chosen 3 numbers as A1, A2 and A3. Now for the remaining numbers A4, A5 and A6, we have to choose from the remaining 4 numbers. So that is, for A4 we have 4 choices, for A5 we have 3 choices, for A6 we have 2 choices, and because again the triplets of this kind, A4, A5, A6, would be treated different as A5, A6, A4 and then A6, A4 and A5, right? They would be treated as different, however they represent the same permutation. So therefore we again are dividing by 3. So therefore how many ways in total would be there in order to create this triplet? So this triplet would be formed when you multiply this number with this number, right? And moreover, this is one thing. Another thing that is repeated over here is the numbers of this kind a1, a2, a3, a4, a5, a6, and the number of this kind a4, a5, a6 and a1, a2, a3. So basically we are just interchanging these two numbers. So we are bringing this one to the front, this one to the back, right? So our permutation is treating this thing and this thing differently. However, they represent the same because two disjoint cycles, they commute with each other. So therefore, they represent equal groups. So that means we are counting such pairs twice in our calculation. So what we do instead is we divide by another 2 in order to get rid of this thing. That means as we are counting them twice, so what we are doing in order to make the result even correct, we are dividing by 2. So when you solve this, you get 280 as the number. So therefore the total we have 70 combinations, 70 ways elements of such kind where we have a1, a2, a3, and 280 where we have such pairs, right? So therefore in total we would have 350 elements which are present in S7 and they have the order 3. So you see how we made use of this result here in order to calculate the elements of S7 which are having order 3. So I hope you understood the result here well. That is it for this video. Thank you for watching.